Okay. This is an introduction of how to make a path, unbuilt path using the Excel software. We have here typical case of interest. We have X and Y coordinate. Those are shown here according to our, let's go down here. Yes, here we go. The shape should be smooth shape, very smooth shape. By smooth, we mean that the first derivative of dy with respect to x, second derivative of y with respect to x should be finite. These, they should be finite. Any shape which have discontinuity will result in high g value. Here, this shape which is selected shows a very smooth. You see, even the g value here. G value means G value here represents the ratio between the reaction force, okay, normal reaction force at the path and the actual weight. So if G is equal to 1 means it is just normal reaction of the, for example, the force with respect to the body. So the weight of the body feels as that his weight is just 1. It is just exact weight. If it is 2, it means that the reaction is twice the weight, and so on. So here the limit is that it should be less than 5. Here this is one case where it is less than 5. The program itself will use your knowledge on how to construct a y in terms of x here. Y in terms, you see the slope, original slope here is negative. It should be negative. If it is not negative, the particle will not start to move here. The gravity is the driving force here. It should start to move, and then it will go up and down. You see here we have one peak, second, third peak, and then the end. Usually the second peak should be less than the first peak, and the third is less than the second, and so on. Otherwise, the system will, because of friction, it may stop somewhere here, and it's not supposed to stop anymore. No stopping, it's not allowed to stop. Okay. Here, according to the calculation of the equation of motion and Newton's law, the speed starts from 0, then it's going up here, and then it's going down and up and down, and then maximum is somewhere here. Okay, so those are the this shows, you see here, maximum, here is minimum. If it is going down, reaching this point here, if you look here, 20, see around 20 here, you see it's like peak and valley here. So here you have the maximum, speed becomes maximum. Then when the y is becoming larger, the speed is becoming less. If you check this point here somewhere between around 30 something, you see around 30, it is like a mountain, all right, and then goes down again between 40 and 50. So here again, it's becoming maximum, all right, and then decrease here somewhere, which is above 60 somewhere. So it's becoming minimum again, local minimum, and then it goes to maximum again at the 80, which is the lowest point. When we compare the solution using the energy method, here we have a comparison using the energy method, which is the red one. Energy has nothing to do with the path. It's relying in the in one concept that the total energy is conserved. You have potential energy and you have kinetic energy. Summation of them should be constant. So using this concept, you can find the velocity in relationship to the y value. So the velocity here is dependent on y value. So the lower the y, the higher the speed. So this happened here. Okay, since the y is a function of x here, the speed will be a function of x the same way. All right. Now using the friction effect here, the speed should go down. Now, based on this, you see we have here friction factor, kinetic friction factor, and this is total air time. If you increase this, make it like 7.5, what will happen here? It is showing that the speed with effect of the friction will become less. And total time, total air time will be increased. If we try to do it as 1 here, 0.1, see the air time is also increased, 9.28. Okay, if the friction factor becomes 0, both solutions will be identical. Okay, so this is the introduction how to use your knowledge to find G value at the end. You see the G value here becomes higher. Y becomes higher here because of now something should use this. Now it's better, okay? See, it becomes higher because here you don't have friction effect is becoming almost negligible, and this will lead or will result into higher speed, less total air time here. Total air time will be less, and the G force will be higher. Okay, G force will be higher. Now, if we make this one as 0.12, for example, here, what will happen to the G force? The maximum is less. The maximum is less. If you make it 0.15, what happens to G force? You see, the G force is becoming less. Air time becomes large. There's a value of friction factor which will stop. See here again the value. The particle may stop somewhere here at a given friction. Let's see if 0.2. See what happened with 0.2. The G force is becoming less. All right, the speed will go up and down here, but the speed is 10. Maximum is 10 somewhere here, 10. And again, with respect to time, the speed level is less. See here, the maximum speed is above 20, but here the maximum is order of 10. If we again increase this, make it 0.21, it will make a problem here. You see, the problem that the body is stopping somewhere. So make it 0.201. You see here, the speed here with respect to distance is going down somewhere at this level. If we make this one a little bit shorter, you see the speed, minimum speed here somewhere It's trying to approach zero. Let's go with this now. Make it as 0.5. You see here, this is the point here. Look here. This point is the speed is almost becoming close to zero somewhere here. Because of this, yeah, see, it shows you clearly what happened. Almost close to zero. So your design, if you select, now mu is fixed, you cannot change mu here. But if you select a longer path, by longer we mean this. I'll show you here. Okay, longer means in the sense let's say that we selected this. What will happen? We may face a problem of stopping here. It will stop. The system will stop. We have to avoid that. We should avoid that. Okay? We should avoid stopping. The idea is not to stop. Okay? This curve, the blue one here, can be generated by using any function of your choice. Because you are not supposed to provide number here just by filling some numbers here like that. No, you have to create a functions, a mathematical functions. Okay, that function should be smooth function, and it should have a negative slope here. Okay, and zero slope there. At the same time, it should have height here should be zero, height here should be h. Okay, so here you have four conditions. A function that should have at least four, not four conditions, yes, 4 or 5, more than this. So you can change, you have one or two parameters, you change them. Okay, once you change them, you have every time you generate a new curve. Okay, this new curve will have okay, set of waves, sort of some waves here. Those waves should be selected precisely or should be selected carefully such that the system will not suffer. It will not stop. Here I'm going to change this and make it 0.05. So you have this at the end. You need to practice your math knowledge. You can either use Derive or you can use MATLAB, for example. MATLAB, you can use MATLAB there. Since you can work in a group of students or group of people can do this. This should rely on teamwork. There should be teamwork to do this. And it is good knowledge that people can practice their math together with their knowledge of dynamics. Okay. Okay, thank you. All the best.